let's get going. I think the 12 point
So I'm here with Jouko Laatsonen from Tieto, and he's about to demonstrate something upcoming from Symbian 4, is that right? You've built on Qt?
Yeah. So you are able to get this Qt SDK already from the Qt web pages, and what you can do with this version is that it's actually bringing you some nice animations. All this is done on software. There's no hardware accelerator existing. We have some kinetic rollings here. We can actually launch the applications, the native applications directly here. Then this allows us to bring some missing UI elements here, like the kinetic rollings, easy animations. All this is available via this.
And this is all in software. This is not using the hardware acceleration at all.
No.
Okay.
This is all done on software, and since this is a beta version of the Qt library running in the top of this device, so it's not anyhow optimized yet. Of course, on the application we had some optimization due to these differences of the devices, but it's basically the beta version of the Qt that allows you to do this kind of things.
So some of these ideas and interface tweaks will appear in Symbian 4, some maybe not make it, but they'll be in the mix.
I think that Symbian 4 will have this technology embedded there, and then there's also going to be this new UI, totally renewed UI, which is being based on the Qt. But of course there are some different UI elements, behaviors that are, let's say, native for the Symbian. This is just an example application what you can do.
Yeah. Very impressive. Thank you very much.
Thank you.
I'm here with Charlotte Falvin from the Astonishing Tribe. Who are TAT and what do they do?
We do software to make user interfaces look better on top of any iOS, any type of device. We provide a UI framework and a UI rendering engine that makes it possible to make the UI look better, be more agile, be more rich, have a better user experience. And that we do for all sorts of manufacturers. We're in every 10th phone that is shipping.
We're from All About Symbian, obviously, so we specialise in looking at Nokia, Sony Ericsson, Samsung smartphones. Which phones that I might have used are the Astonishing Tribe technology in?
Well, if you use Sony Ericsson phones, the chances are extremely high that we're in that. In the Nokia S60 3.2 version and onwards, you'll most likely have used our technology or a user interface that has our technology as a way of presenting the UI and make it more rich.
So theme effects in S60 3.2 are actually part of the TAT technology?
That is right.
Okay.
That is right.
Okay. Have you any demos you can show me today?
Of course, we can bring some up.
This is also Frederick Adamar, also from the Astonishing Tribe, and he's about to demonstrate.
Yeah, so what we have here is an example of, actually I can pause it. It's what we're doing quite a lot is to work with hardware manufacturers and SoC companies like TI and so on and so forth to essentially show off what coming generations of hardware can actually do in terms of compelling user experiences. So in this case we have a demo. We've done lots of these demos with different manufacturers. In this case it's a demo running on an ARM Mali based platform, and this was first shown at the ARM partner meeting a month ago. And it's showing off a little bit what you can do with, I don't know how well it comes through, but it's showing off an example of what a future 3D user interface could look like. And you should look at this and more as an example of various types of the UI patterns that could be relevant in a 3D user interface. So this is totally sort of running off of hardware that's available today. it gives an idea of what you can do with OpenGLA's 2 shaders, for instance, to create materials, to create full meshes where you navigate in 3D space. Like in this case, you have widgets in the background, which you can and you use the spatial metaphors a little bit more vividly than in previous examples. So we do quite a lot of these demos. And this was one of them.
And that was hardware accelerated using...
Yeah, for sure. So it's a wide VGA screen, and it's, as I said, you're using OpenGLA's 2 for creating shader effects, materials, lighting, shadows, stuff like that. So we think that going forward we see a lot more of these, not exactly like this UI, but in the lines of those types of UIs at least, and also bringing in external sort of passive inputs from accelerometer, from gestures, from novel ways of creating output, like for instance with the Pico projector. So you combine a small screen with a big screen, projected screen. So there are lots and lots of interesting opportunities with emerging hardware as we see it.
Okay. Thank you very much. It's Gautier Chastain from Stantum with their resistive and multi-touch system. So what are you showing me?
So I'm showing you one of our licensees implementation. So it's a one-chip solution for implementing the multi-touch. And what's very interesting with the technology, it's a major step ahead of standard analog resistive. We have some kind of patterning which enables multi-touch, and it enables, I'm going to show you a few features.
Does this replace the standard resistive grid, or is it in addition to the normal resistive touch screen?
No. It's there's a patterning of the existing resisting layers.
Okay.
So you don't have to add another layer on top of it.
Okay, right.
Let me do this. The first thing, this is true multi-touch, so you can have many fingers.
Yeah.
So I think it's not even useful to have more than these on this device. And so this is very good in terms of there is no limitation.
And it's very fast running on. I see it's running on an OMAP.
Yeah.
Graphic acceleration system. Yeah.
And second point is it can work with any contact object. So like for instance this, that, or even.
Yeah.
So you don't need expensive digitizers like type of pens. You don't need. It's working straight ahead. With
what about power requirements? Is it battery hungry or power efficient?
No, it's not, because basically the way the technology is handled require very low power. For instance, if you don't actually touch the device, it will scan very fast to see if there's a touch anywhere. Okay? And you don't have to scan all the time every cell, and the way the technology itself is embedded enables very low power consumption. Because like for ProCap you have to monitor, and there is a very expensive processing power required by ProCap, like capacitive technology. Which is not the case.
How much do you think it will add to the bill of materials for a phone in 2 or 3 years' time?
I can't tell you now. I can't tell you now.
Okay. And presumably this obviously can't work through glass. You still need a plastic touchscreen, plastic top layer to allow the depression.
We have glass touch panels. So
using capacitive.
No. With this kind of technology, you can have glass touch panels. So it's working with PT on PT, PT on glass, glass on glass. You can have your choice.
So you can detect the pressure through a thin sheet of glass.
Yeah.
Okay. Right. Thanks very much.
You're welcome.